Okay, last couple of examples here. We'll do 7, 8, 9, and then we'll save the remaining part of the examples for when we meet again. Okay, so the limit as x approaches infinity. All right, if we have 3x to the 8th minus 7x plus 9 divided by 7x cubed minus 4, again, I could take these individually and apply the limit as x approaches infinity to just the top, the numerator, or just the denominator. So if I look at the numerator, as x approaches infinity, I have 3x to the 8th driving this function. That's an even degree, so my end behavior will be moving in the same direction with a positive leading coefficient, which means as x approaches infinity, my outputs will also approach infinity. And then as x approaches infinity in the denominator, I have an odd degree with a positive leading coefficient. And that end behavior as x approaches infinity will also be approaching infinity. So here we are again with an indeterminate answer. So let's look at the graph for this function. And you'll notice that the graph for this function does not have any horizontal asymptotes. Okay, the previous two graphs, clearly as x approached infinity or negative infinity, you were approaching some horizontal line. That is not the case for this graph. And so let's see analytically what that means for us. All right, so again, we're going to look at the end behavior model. Okay, and that means that I'm going to look at the limit as x approaches infinity of the largest degree, the term with the largest exponent in the numerator, and the term with the largest exponent in the denominator. And what I noticed in this particular case is that the degree in the numerator is larger . So again, I can go through and simplify this expression like we did previously. X to the 8th divided by x cubed, okay, is going to mean that I have the limit as x approaches infinity of 3x to the 5th over 7. And now this is really the same as saying 3/7 x to the 5th, right? I have my variable left in the numerator. Again, I can't substitute infinity in for x. Okay, but what's going to happen is that when I substitute infinity in for x, my function is going to grow larger and larger and larger. Because I have positive terms as my coefficients, I have a polynomial with an odd degree, positive leading coefficients. So overall, I'm going to be headed towards positive infinity. Which, again, when you look at the graph, that matches, right? As x approaches infinity, or as I move to the right, my function's end behavior is moving towards larger and larger y values, okay? Now, in none of these examples did I do the limit as x approached negative infinity. And so let's take a minute and explore that a little bit, especially since we have a graph, okay? So let's say that I did the limit as x approached negative infinity of this overall function, 3x to the 8th minus 7x plus 9 divided by 7x cubed minus 4. Well, again, I'm still going to look at the end behavior model. Okay, no matter what, I'm going to end up with something like infinity over infinity, negative infinity over infinity, some combination. So I'm still going to look at that end behavior model, 3x to the 8th over 7x cubed. Well, hey, that still simplifies like we did up above. The limit as x approaches negative infinity of 3/7 x to the 5th. But now I'm saying as x moves to the left, as x approaches negative infinity. And remember, when I have a positive leading coefficient and an odd degree, if I look at the left side of my function, the outputs are approaching negative infinity. And so you really have to pay attention to the x value. Is it approaching positive or negative infinity? But you also have to pay attention to the sign of the coefficients, okay? Let's pretend that this was a negative 3x to the 8th over 7x cubed. So when I simplified, I had negative 3/7 x to the 5th. Well, then I would have a function that looks like this. Odd degree, negative leading coefficient. And so if I'm still looking at the limit as x approaches negative infinity, now, because of my negative leading coefficient, my overall limit approaches positive infinity. So I'm doing these basic examples to get you thinking about the end behavior model and applying that limit. But you have to pay attention as you move through your practice tomorrow. You have to pay attention to what x is approaching. You have to pay attention to the sign of the leading terms. You have to pay attention to the degrees of the leading terms and what the end result's going to be. So when the degree in the numerator is larger, I just want to summarize this here real quick. We're going to say that there's no horizontal asymptote. There is no y equals some specific number, not approaching a specific y value. All right, so last example here, number 8, the limit as x approaches infinity, 3x to the 7th minus 7x plus 9 over 7x cubed minus 4. Okay, again, if I were to graph this, there would be no horizontal asymptotes. I want to look at that end behavior model. I'm just going to abbreviate at this point, end behavior model. And when I look at that end behavior model, I'm looking at the limit as x approaches infinity of 3x to the 7th over 7x cubed, okay? And again, I can simplify this like we had done previously. This becomes the limit as x approaches infinity of 3x to the 4th over 7. Now I have an even degree. In 7 I had an odd degree. Positive leading coefficient. So as x approaches infinity, the right-sided end behavior, my outputs approach infinity. Again, there was no horizontal asymptote. And these results could change depending on what x is approaching, positive or negative infinity, depending on the sign of your leading coefficients, and depending on the degree that you are left with when you simplify. All right, so I just want to wrap this up in general. Okay? In general, we could say that when evaluating limits at infinity, meaning as the limit as x approaches positive infinity or negative infinity, okay? You're determining the end behavior of that function. Okay, you may have a horizontal asymptote, okay? Horizontal asymptote is possible, and if that's the case, you write it as y equals, okay? Or you may have no horizontal asymptote, all right? So things to think about. You have no assignment tonight, but you do have a practice assignment for Delta Math tomorrow to start to practice the things that were discussed in this video. Again, things to consider is what is x approaching for your limit? Is it approaching positive or negative infinity? What is the sign on your leading coefficients in your end behavior model? Is it positive or negative? How do you create the end behavior model? You pick the term with the largest exponent in the numerator divided by the term with the largest exponent in the denominator. And then once you simplify that end behavior model, what is the degree of that simplified function? So those things are all going to contribute to your answer. What x is approaching, the sign of your end behavior model, and the degree of your end behavior model will determine if you're approaching a specific number, horizontal asymptote, or if you're approaching infinity or positive infinity, in which case technically the limit does not exist. If you have questions, email me and let me know. See you next time.